Okay, we've got a bunch of things to figure out about two vectors here. We're given u and v in component form, and we're asked to find the magnitude of each, the dot product, the angle between them, and so on. So I'm going to start out with the easy ones. Let's talk about u and v. Magnitude, remember, magnitude of a vector, like u, is simply equal to the square root of the sum of the squares of its components. This is basically a complicated way of saying Pythagorean's theorem. So what do we get for this one? We get the square root of, let's see, 1 squared plus 2 squared. Couldn't be easier. Square root of 5. Okay, so that is the magnitude of this vector u. Now the next one, v, is approached in much the same way. You simply take the square root of the sum of the squares of its components, u, v, okay, which is going to be equal to, let's see, the square root of, well, negative 3 squared plus negative 5 squared. And that equals, let's see, 9 plus 25. Looks like we're getting radical 34 for that one. Okay, so that's the easy stuff. Now let's get into the dot product, which is a really useful thing. I'm going to say the dot product of two vectors, and I'm going to give you two formulas. We're going to use them both. On the one hand, it's equal to the product of the x components plus the product of the y components. Okay, that's a very important one, and for us, that's what we're going to start with. But it is also equal to the magnitude, the product of the magnitudes of the vectors times the cosine of the angle in between them. And that's how we're going to approach the next step after this. So, very first part, this I can approach easily. The x component of u is 1, the x component of v is negative 3, the y component of u is 2, and the y component of v is negative 5. Okay, so that's going to be equal to negative 13, I think. Great. So there's my answer there. Now for the next part, let's finish using the other side of this equation. Okay, this is radical 5 times radical 34 times the cosine of the angle in between them. Well, look what we can do with this. We can just say, negative 13 divided by the square root of 5 times 34, 150, 170. Negative 13 divided by the square root of 170 equals the cosine of the angle we're looking for. So you take the arc cosine of each side. And for this one, what I got was 175. I got 175.6 degrees. Okay, so we put that in here. Remember to check whether your calculator is in degrees or radians. That's kind of an important point. And at this point, it's also useful to just double check. Mistakes happen. Your job as a mathematician is to figure out your mistakes. So I would check myself this way. I would say, okay, here's u. All right, that's my vector u. And my vector v is negative 3, negative 5. So, I don't know, like this. Negative 3, negative 5. There's v. What's the angle in between them? Well, it's a pretty big angle, right? It's almost 180 degrees, not quite. That 175.6 looks pretty good. Now, the next question. Are they orthogonal? Okay, let's drill down onto this word. This is an important word right here. What does orthogonal mean? That basically means perpendicular. Well, how do you know if two vectors are perpendicular to each other? The angle would equal 90 degrees. It would have to be 90 degrees. That's what perpendicular angles look like. And we clearly are not 90 degrees, so this is a big old fat no. They are not orthogonal vectors. Now, one last part here. The orthogonal projection of u onto v. Kind of complicated equation. Let me draw what we're talking about here first. If I have two vectors, okay, here's one, I don't know, here's another one right there. The orthogonal projection of one vector onto the other, let's say the orthogonal projection of u onto v, like this. This is not the picture above, I'm just giving you an idea. It would be this. It would be the amount of u that goes in the same direction as v. Okay, so you would basically just drop a perpendicular line down to v and say how much of u is in agreement with v. Okay, so that's the idea. Now, what we've actually got going on here is a complicated equation. It looks like this. It's going to be equal to the dot product, okay, fortunately we have that one already, divided by the magnitude of v squared. Now we have the magnitude of v already, so that's not too bad, times the vector v. Okay, so kind of a lot to put in here, but let's just put everything together. Now the dot product, we already figured out earlier, is negative 13 in this case. The magnitude of v squared is going to be 34. And then I just multiply that by the vector v. Now the vector v was negative 3, comma, negative 5. So we just multiply the scalar into the vector and see what we get. This is going to be, looks like 39 over 34, comma, 65 over 34 once I complete that multiplication. Okay, this is the orthogonal projection of u onto v.